Okay, so in case chapter 3 has made absolutely no sense and you're trying the homework or the other review sheet that's on blue paper this weekend and you'd like it to make sense, but it doesn't, hopefully this extra example might make things slightly more clear. So pretend we've got this made up data here about going to homecoming, not going to homecoming, undecided, and it's broken down by gender, female and male. So the first thing I would do to start answering these questions is to find some totals. Ooh, it's gonna fall. All right, we're just gonna bring it down here. Okay, so we need totals. So there's 25 going to homecoming. There's 10 not going to homecoming. And there's 5 currently undecided. And then if we count going across, there's 15, 22 females, and there's 18 males. Oh, you can't see. Okay, there we go. Okay, so there's our data. Now we're going to answer a whole bunch of questions. So we're going to just see how this goes. All right, so say we wanted to answer, we should probably add up the big total, so 25, 35. So we've got 40 people represented all together. So let's put, I'm just going to put it in a box. 40 people all together. Okay, so when it's asking what percent of the class, this is our denominator. So what percent of the entire class, so out of 40 people, how many of those 40 people are not going to homecoming? So not going to homecoming, 10 out of 40. And on the quiz, it might be as a percent instead on the multiple choice question. So there we go, 25%. Okay. Now the wording is really important. So for this next one, it says what percent of females. So this is now our denominator. So basically out of all of the females. So the females, out of those 22, how many of those 22 are in the undecided about homecoming category? So there's the 2. So we would have 2 out of 22, which is about 9.1%. Okay, so again, when it says what percent of females, it's only the females that we're interested in, which makes them be the denominator. This next one, again, just to get a bunch of different examples out there. What percent of the going to homecoming people are male? So that means you've got a huge group of going to homecoming. So out of all the going to homecoming people, which is this part of the table, so out of those 25, how many are male? So we look out of these 25, here's our guys. So 10 out of 25 would be 40%. Okay. All right, now we're looking at one that has some kind of funky wording. So it says, what percent are female given a person is not going to homecoming? And I realized, hence the whiteout, this given is something different that we did not talk about in class. So it won't be on the quiz, but just for those of you who like to know all things, it's going to come up later in our probability chapters. So when it says what percent are female given that a person is not going to homecoming, this is telling us we know stuff. We know this thing afterwards has happened for sure or is happening like first. We know this stuff. So this given is code for we know the person is not going to homecoming. So all of the people not going to homecoming are 10. And out of those 10, what percent are female? So the females not going to homecoming is 5. So 5 out of 10 would be 50%. So again, that given will come up later. It's just on here so you can see how it looks before the probability chapters come up, like chapters 14, 15, 16, and 17. Okay, another word that we did talk about is this concept of, let's just move all this, is marginal distribution. Okay, so there's 2 different marginal distributions on every table. There's a marginal distribution on this edge, these three numbers describe homecoming, not going, or undecided. So those numbers will be the marginal distribution for like homecoming status. These edge numbers over here, our 22 and our 18, they're describing male and female. So they are the distribution we want. They're describing our gender. So when it says to give percent, we would want to figure out what percent of this group of people are going female, and what percent of this whole group are male. So we'd have so females would be 22 out of 40, which would be 55%. And our males are the other part of our distribution of gender. Our males would be the 18 out of 40, which is the other 45%. So our 2% do add up to 100. There's 100% of our people are either female or male. And that's our marginal distribution found on the edge of the table where margins are. Edge of the table, these two numbers describe gender, male and female. The other kind of distribution is a conditional distribution, and this is really nice to know how to do because it helps us make a segmented bar chart. So it says, this next one here, let's move this so we can, there's too much stuff. Okay, there we go. Okay, so find the conditional distribution of gender for people who are undecided. Okay, so it's telling us this condition for this problem, the thing we absolutely positively know for sure is we are undecided on homecoming. So this is our denominator. Okay, so the undecided group is broken down by gender. So we have females that are undecided, we have males that are undecided. Okay, so again, this is asking us to focus. The conditional distribution of gender, that's the part that varies. They could either be male or female. For the people who are definitely undecided, here's the condition we're looking at. So for these 5 undecided people, how many of the 5 are female and how many of the 5 are male? So we have 2 out of 5 are female, or 40%. And we have 3 out of 5 are male, which is 60%. So we've got 100% of our undecided people are accounted for, 40% are female and 30% are male. So that would be a conditional distribution example. The other thing that we've done in Chapter 3 is ask if gender and homecoming status are independent. Explain using a graph and words. So we can actually use the information we just did, the one where we had our undecided folks, and we found that conditional distribution. So I'm going to go ahead and use the information we just did. And I'm going to use that. Oh, you can't see. Here's my chart. Okay, so we have the undecided group. We also have the not going to homecoming group. Not. And this is homecoming group. Okay, so our undecided group, if you're making a segmented bar chart, that's the best and easiest way right now to figure out if 2 variables are independent. You pick a variable, either male or female, or because I just did the previous question about conditional distributions, I've chosen homecoming, no homecoming, and undecided. So I just did this breakdown here of gender for the undecided group. 10, 20, 30, 40, okay, 50, 60, 70, 80, 90, 100. These are relative frequencies up here. All right, so I just did the breakdown of the undecided bar. And for my undecided bar, my conditional distribution was that 40% were females and 60% were males. So I've already done the work for that particular bar. So I'm going to go ahead and use the 40 and the 60. So over here on my undecided bar, 60% were male, and this 40% is female. So that's the work I just did. I also need to make a conditional distribution bar for not going to homecoming. Okay, so we can do a little bit of mental math here. There's 10 people total not going to homecoming. It's divvied up 5 out of 10 and 5 out of 10. So I think we're probably okay doing the math. Half of the people not going to homecoming are female, and half of the people not going to homecoming are male. So I'd go right here at my 50%, and I'd draw the line there. So these are males and these are females. So within my not going to homecoming bar here, we're split evenly on gender. Whereas people that are undecided on homecoming, based on this graph, they're more likely to be male than female. And then finally, for my going to homecoming conditional distribution bar, so up here, we've got 25 people going to homecoming. There's a very large difference here, 25 total, 10 total, 5 total. By converting the numbers into percents, it's much easier to compare. So it would be difficult to compare a group of 25 to a group of 5. Making these y-axis be relative frequencies with percentages, it's easier to compare these unequal sized groups. So with our last bar here, our homecoming group, there's 25 people total, 10 out of 25 are male. So doing some quick math, I don't know what 10 out of 25 is. I think that's 40%. So 40% male. Our other remaining 15 out of 25, or 3/5, which is 60%, would be female. So that would be my conditional distributions. We're breaking down gender for each of the categories: homecoming, not going to homecoming, and undecided. So the final part after you've got this graph is basically, what is the graph telling you? So I like to picture it, if someone came into the room and I noticed that they are female, based on this chart, my females are more likely to be going to homecoming than to be present in these two groups. So knowing someone's gender gives me what I like to say is extra information about the other variable. As soon as one variable gives you extra information about the other, the two are not independent. So I like to think of it that way. So I would write something like gender and homecoming status. It's nice to practice writing in complete sentences now. AP test readers really like that. So gender and homecoming status are not independent. It's kind of difficult to jump and say that they depend on each other. So I just like to use the phrase they're not independent versus jumping to the more strongly worded, well, it depends on your gender. Maybe going to homecoming has a lot to do with, do you have a job, how much money you have saved up, things like that. It's not necessarily dependent on gender. It's just, we're saying not independent. I realize that's a little weird. Gender and homecoming status are not independent because the conditional distributions are different. So we have drawn 3 different conditional distributions, and the breakdown of gender within each is different. So because the conditional distributions are different. So I hope that helps a little bit of chapter 3 make more sense.